Hey guys, Mr. Ground here. This is 7.1 dilations. So what is a dilation? A dilation is a type of transformation that makes something larger or smaller. Notice that the shape stays the same. So this is really like a little version of the same triangle. This is the big version of the same triangle. They're all proportionally the same. How much larger or how much smaller we make it is called the scale factor. So the scale factor, if all the sides are twice the length as the pre-image, that means we have a scale factor of 2. And if we started with this pre-image and shrunk it down where all of these are now 1/2 the size, that means it has a scale factor of 1/2. Now, dilation, if you think about, like if you've ever been to the eye doctor, right, and they put the drops in your eyes and it dilates your pupils so they can see into the back of them, that's why they call it dilation, because your pupils get bigger. They don't change shape, they just get larger. All right, now the scale factor, this is that common ratio that we multiply by to get the new image. So all the lengths of all the sides change by the same scale factor. If that K value is greater than 1, it's an enlargement. If it's less than 1, it's a reduction. Notice that it's the absolute value because we can have negative numbers sometimes with these, and it's really the size of the number. So like a -4 would still be an enlargement even though -4 is less than 1. And basically anything that's like a decimal number or a fraction, that's your reduction. That's going to make it get smaller. Okay, so looking at these, in dilations, everything that has a dilation applied to it, it's proportional, right? Meaning that it's the same ratio of sides for all of these. So if it's like 3 units by 2 units, then it could be like 6 by 4 or 9 by 6 or something like that, where it follows the same ratio. So what we can do is we can compare all the side lengths of the image and the pre-image and the image. So for our image, if we look at AB, that has a distance of 3, right? BC has a distance of 2, and then C to D is also 3, and D to A or AD is 2. So our side lengths are 3, 2, 3, and 2. For our image, right, now if I count up for the image of AB, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 1, 2, 3, 4, 5, 6, and then 9, and then 6. And so A prime, B prime has a distance of a length of 9. BC is 6, 9, and 6. Now, if these are proportional, meaning that this is truly a dilation, all of these ratios should be the same, right? It should make the same fraction. So if we put the new, when we're doing this, we'll put the new or the image over the old and use that to see if we've got a common scale factor, right? So that's going to be 9 over 3, which equals 3. From B to C, it's 6 over 2, which equals 3. C to D is 9 over 3, which equals 3. And then 6 over 2. So because all of these scale factors are the same, that means that these are proportional, and this is a dilation. Something didn't get distorted or anything. It didn't stretch one way more than the other. It just got larger. All right, another example, comparing the side lengths here. So same idea, we want to measure our sides. So from X to Y, that is 1, 2, 3, 4, 5, 6. And then Y to Z is 3, and then 6, and then 3. And then in our image, X to Y is 2, and then 1, and then 2, and then 1. Right, so we went 6, 3, 6, 3, and 2, 1, 2, 1. So let's see what our scale factor is. So so the new over the old, right? We always want to do that, new over old. So 2 over 6, that is a fraction that reduces, and it reduces to 1/3 because they're both divisible by 2. And then 1 over 3, and then 2 over 6, that again reduces to 1/3, and then another 1 over 3, like that. And so are these shapes proportional? Yes, and our k value would be 1/3. All right, so now, looking at what the scale factor is. So is this an enlargement or is it a reduction? All right, so remember the pre-image is the one where it's just the plain letters, and the image is the one with the primes, right? So again, we want to do the new, like how did it change over the original? That's what we want to look to. So now we're not going to do it for all the lengths. I don't have all the information. I think it's given in here that that this is a that it is a dilation. They are proportional to one another. So my new one, the one with the primes, is 18. And the old one, the one without the primes, that equivalent side, the corresponding side, is 12. All right, so 18 over 12. Let's reduce this fraction. They're both divisible by 6. And so we have a k value, a scale factor, of 3 over 2. So this is an enlargement. So that's an enlargement. So we went from our original, the black one, we kind of see that it got bigger, right? And how much bigger is it? Well, it increased by a scale factor of 3 over 2. All right, and then our next one. So now we're going from the black triangle to the red triangle. Now, if we assume that these are proportional, let's just pick an easy side to count on. So why don't we go BA, because that's the shortest side. So that is 2, and this one, B prime, that's 1. So in this case, we put the new one, the prime one, which is 1 over the old one, 2, and so that is a scale factor of 1/2, and that is a reduction. Right, so we went from the black one and we shrunk it down to the red one.